Project evaluation. Hello, everyone. Today I'll be sharing our proposal for a sustainable energy system for rural property in Wooton, New South Wales. Our goal is to design a system that's reliable, eco-friendly, and affordable, while also being ready for future needs like electrical vehicles. To guide our design, we use system thinking and sustainability frameworks like natural step, the precautionary principle, and industrial ecology. We also ran a pestle analysis to consider political, environmental, and social factors. We compared three options. Option A, basic grid connected. Option B, grid connections with battery storage and EV integration. And option C, off-grid hybrid with solar, wind, and diesel backup. After evaluating costs, environmental impacts, and future potentials, option B came out on top. It's the most balanced, scalable, and sustainable choice. So we recommend option B as a long-term solution for the client.
Problem definition and problem analysis. Rural limitations to infrastructure result in high lifecycle emissions from the current grid connection, higher energy cost, and insufficient supply stability. The task is to optimize SES to become grid independent, minimize emissions and operating costs, and enhance performance and resilience. Pro- for problem analysis, we look at aspects like technical aspect, economic aspect, social aspect, and environmental aspect. Project plan considerations. In designing the sustainable energy system for the Wotton property, our approach started with clearly defining the project scope and identifying all critical stakeholders from the property owner and design team to engineers, community reps, and local councils. Communication was key. We scheduled regular internal design reviews and bi-weekly client updates to keep everything transparent and agile. We also performed pestle analysis to anticipate external influences. This revealed both challenges like regulatory hurdles and bushfire exposure, and opportunities such as government solar incentives and community empowerment. Pestle analysis. We use pestle to map key external factors. Politically, we may face zoning delays, but incentives support solar adoption. Economically, costs are high upfront, but savings and feed-in tariffs help long-term. Socially, systems must suit rural lifestyles with a chance to inspire local communities. Technologically, we need future-proof solutions. The good news is tech is improving fast. Legal risks include permits and heritage, but laws increasingly support off-grid living, and environmentally, bushfires are a concern, but solar systems boost resilience and cut emissions.
Hello everyone. I will briefly talk about our life circle assignment for the three energy options. First, we'll look at manufacturing emission, for example, making solar panel, batteries, and other equipment. This is called embedded emission. Secondly, we consider optional emission, meaning from using grid electricity or data for over 10 years. There are three options. Option A has lower manufacturing emission, but it still depends on the grid, so it has more optional emission. Option B has bit higher manufacturing emission, however, it uses less grid electricity and can charge electricity vehicle. This reduces total emission over time. Option C avoids grid but it needs bigger battery and use diesel emission, sometimes which add more emission overall. In our calculation, option B show the lowest total emission after 10 years due to bigger solar capacity and the potential to power EVs cleanly. Therefore, we recommended option B as the best choice for reducing carbon emission in the long run. Thank you for your listening.